Finishing up section 13.8 here, example 3 is sketching a graph. What are the graphs of y equals sine of x and y equals cosecant of x in the interval from 0 to 2 pi? So, first thing we're going to do is set up our graph. We want from 0 to 2 pi. So, again, I'm going to split it up into my 4 even pieces, and 2 pi is going to be my last one. To figure out my others, I take 2 pi divided by 4 because I split up that span into 4 pieces. I fourthed it, I quartered it, so we divide it by 4, and I get pi over 2. 2 out of both of those. So pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. Okay, pi divided by 2 is just pi, and 4 pi divided by 2 is 2 pi. I'm going to go ahead and set my amplitude. Here it's just 1. So I'm going to go 1, negative 1. So sine, I'll do it in purple here, 0, max, 0, min, 0. And this is one cycle of the sine curve. Now, cosecant is the reciprocal. That's not going to show up on the graph. Let's try this. Of sine. So, instead of having 0, I would have 1 divided by 0, which I can't have. So we have an asymptote. Instead of having 1 is still just 1. But like right here where it's, let's say it's about half, okay, the reciprocal of that, flip it, is 2 over 1. So I go about even distance here. Same thing, about even distance here. Okay, again 0. I can't have 0. When I take the reciprocal is 1 over 0. Can't do that, so it's an asymptote. Same thing here. 1 over 0, we can't do. So when sine is 0, cosecant of 0 is undefined. Undefined. We draw in the asymptote. Negative 1, the reciprocal is still just negative 1. But when I'm up kind of like a half or wherever that happens to be on our graph, it goes the opposite direction. So instead of being like 1 over 2, it's 2 over 1. So we're going to be somewhere down here. Okay, not exact values. We can find exact values, but here when we're just doing a sketch, I don't need them. Okay, cosecant. The only exact values we need here, guys, are asymptote, maximum of sine, asymptote, minimum of sine, asymptote. So the red is our cosecant. Tangent and cotangent from 0 to 2 pi. Okay. So, tangent from 0 to 2 pi. Okay, remember tangent is y over x, or sine over cosine. So, tangent, sorry, I forgot to split up my graph here. 0 to 2 pi again, so 2 pi, pi over 2, 2 pi over 2, or just pi, and 3 pi over 2. Okay, tangent has asymptotes. Got pi over 2 and 3 pi over 2. Okay. The tangent in red. 0, halfway in between, it's at 1. And then goes towards the asymptote. halfway in between our asymptote and our next 0 is 1. Halfway between 0 and our next asymptote is 1. 1 or negative 1. Halfway in between negative 1 and 0. So it looks like this. That is our tangent curve. Tangent curve is increasing from left to right. Cotangent is the reciprocal of tangent. So we take our points and we check them. Here I have 0. So when I take the tangent is 0. So cotangent is 1 over 0, which is undefined. So we put an asymptote here. Okay, our next value is we have pi over 4 and 1. Okay, halfway in between there's pi over 4. Okay, so at that same spot, cotangent is 1 over 1, the reciprocal, and we get 1. Where tangent is undefined, that means we have a number divided by 0. Undefined. Cotangent then takes 0 divided by a number, which gives us 0. So our asymptotes move. At negative 1, the reciprocal is 1. At 0, the reciprocal is undefined. We cannot divide by 0. At 1, the reciprocal is 1. At undefined, the reciprocal is 0. And again, here, where tangent is undefined, that means that we had tangent was some number divided by 0 to get undefined. We get undefined with division by 0. So the reciprocal means it's 0 divided by any number. And 0 divided by any number is 0. Okay, the reciprocal of negative 1 is negative 1. And the reciprocal of 0 again is undefined. Okay, tangent to be 0 means it was 0 divided by any number. So its reciprocal is any number divided by 0, which we can't have. Undefined. So cotangent looks like this. And my curves are even worse for cotangent than they are for tangent. Okay, so same shape. The only difference is cotangent looks like a negative tangent, kind of, and it shifted over just a little bit. So tangent has asymptotes on odd pi over 2s, and cotangent has asymptotes on even pi over 2s, or just pi's. Okay, a lot of times, even I've been doing this stuff a long time, but even when I go to graph these, I usually graph like sine, tangent, or cosine first, and then take the reciprocal of it. Example 5 on page 887 here. A restaurant is near the top of a tower. A diner looks down at an object along a line of sight that makes an angle of theta with the tower. The distance in feet of an object from the observer is modeled by the function d equals 601 secant of theta. How far away are objects sighted at angles of 40 degrees and 70 degrees? So, here we're in degrees, so make sure you either use the degree key or switch to degrees in your calculator. But we have something like this. We have a tower, and at the top, it looks kind of like the Space Needle or something. I'm not sure. Okay, that's here's some windows so people can look out. Okay, and if we look from here to some point on the ground, okay, that's our distance. This is our theta value, and we know that the height is 601 feet. So, it makes a triangle here. They've told us that distance equals 601 secant of theta. And we can use, guys, SOHCAHTOA here. Opposite over hypotenuse, adjacent over hypotenuse. So they just solve for D by using secant instead of cosine. But they mean the same thing. So our distance here, well, they mean the reciprocal, they're comparable, is the same as cosine of our theta value. And that's how we type it in our calculator. So 601 divided by cosine of 40 degrees and 601 divided by cosine of 70 degrees. And when we do this, again, either make sure your calculator is in degrees or you use the degree button, and that's 2 up from cosine, 1 down from the delete. I got for 40, does it say how to, doesn't say how to round, so 784.5, and this is in feet. For 70, we should get approximately 1757 feet. So the only thing here, guys, that we're really working on is making sure we can switch from secant to cosine. The Goddard problem's the same idea. They just use 553 instead of 601, and then different angles, but same concept. Sine, cosine, and tangent have reciprocals. Cosine and secant are reciprocals. Sine and cosecant are reciprocals, and tangent and cotangent are reciprocals. Reciprocal trigonometric functions can be evaluated using what we know about sine, cosine, and tangent. And the graphs of reciprocal trig functions have asymptotes when their denominators equal 0. And there is your assignment for the last section of advanced algebra.